Hello, 6th grade math students. This is chapter 7.3, Simplifying Algebraic Expressions. In this chapter, we'll learn to simplify expressions with one variable, and we'll learn to recognize that the expression obtained after simplifying is equivalent to the original expression. Let's get started. Let's begin with exploring the basics of simplifying an algebraic expression. A straw of length y inches is joined to another straw of the same length. What is the total length of the two straws? So the total length of the two straws would be y inches plus y inches, which is the same as 2 times y inches, which is the same as 2y. So the simplified expression is 2y. In this particular expression, the 2 gets a special name. It's called a coefficient to the variable. Let's look at another example. The triangle you see here has 3 equal length sides, each p centimeters in length. Find the perimeter of the triangle in terms of p, then state the coefficient of the variable. To find the perimeter, we need to add the length of each side together, which gives us p plus p plus p. There are 1, 2, 3 p's, so our answer is 3p. So the perimeter of the triangle is 3p centimeters. In the term 3p, the coefficient of p is 3. Let's look at one more example before we have you try some on your own. This figure shows 6 rods and their lengths. Find the total length of the 6 rods in terms of z. Then state the coefficient of the variable in the expression. Okay, so let's go ahead and begin by simply adding each of our lengths together. That would be z centimeters plus z centimeters, that takes care of these two, plus z centimeters, plus z centimeters, plus 2 centimeters, plus 5 centimeters. All right, so first we're going to add together our variables. We have 1, 2, 3, 4 z's. And then we're going to add together our digits. 2 plus 5 equals 7. So the simplified expression is 4z plus 7. So our total length of the 6 rods is 4z plus 7 centimeters. In the term 4z, our coefficient is 4. All right, let's have you try a few of these on your own. Here are 6 practice problems for you to try on your own. For numbers 1 through 4, simplify each expression, then state the coefficient of the variable in the expression. So you'll have 2 answers for 1, 2, 3, and 4, the simplified expression and then the coefficient. For number 5, find the perimeter of the square in terms of x. Remember, these little tick marks mean that each side is of equal length. So every place you see that single tick, that means those sides are also x centimeters in length. So you have 1, 2, 3, 4 sides, each x centimeters in length. And finally, for number 6, find the perimeter of this trapezoid in terms of w. And the unit on each of the w's is centimeters. So you'll be solving for the perimeter in terms of w with a unit in centimeters. Press pause while you work, and we'll come back to a new idea when you're done. Our next idea is that like terms can be added. So given the statement 3x plus x, how would we simplify that statement? Well, we can rewrite this as x plus x plus x to represent our 3 x's, and then add our final x plus x. So we have 1, 2, 3, 4 x's, giving us the simplified answer of 4x. Another way to think about this is to simply add the coefficients. 3x plus, and remember, there's an invisible 1 in front of that single x. So now you just add your coefficients, 4, and put your variable back on, x. So the simplified version of 3x plus x equals 4x. We call 3x plus x and 4x equivalent expressions because they're equal for all values of x. No matter what value of x you would substitute in, those two statements would be equal. Now let's simplify 4z plus 2z. We'll start by adding our coefficients. 4 plus 2 equals 6. Then we'll put our variable back on, z. So 4z plus 2z equals 6z. Here's a few more practice problems for you to try. For numbers 7, 8, and 9, please simplify the expressions. For number 10, 11, 12, and 13, please look at the two statements you've been given and determine if the expressions are equivalent. For example, in number 10, is 3a equivalent to a plus a plus a? So your answer to 10 through 13 will either say equivalent or not equivalent. Press pause while you work, and when you come back, we'll subtract like terms. As promised, let's subtract like terms. Let's simplify 2v minus v. We can do this exactly the same way that we simplified by adding. First, let's look at our coefficients. 2 minus 1 gives us 1. And then we put our variable back on, v. In this case, you can actually just write your answer as v. We don't have to show the 1. Now let's simplify 5w minus 3w. Once again, we'll start with coefficients. 5 minus 3 equals 2. And then we put our variable back on. So our simplified statement is 2w. Remember, our coefficient is 2. Finally, let's simplify y minus y. What's that going to give us? 0. Anytime you subtract a number or a variable from itself, you always get 0. Okay, let's try some practice problems. Here are 5 more practice problems for you. In 16, 17, and 18, please simplify. In 19 and 20, please state whether each pair of expressions is equivalent. Press pause while you work, and we're going to visit our dear Aunt Sally when you get back. Okay, let's use PEMDAS to simplify algebraic expressions. We'll begin with one that's pretty straightforward. X plus 6x plus 2x. So since our operations are all the same here, we're adding for everything. All we need to do is work from left to right. So 1x plus 6x is 7x plus 2x. And now 7x plus 2x equals 9x. So the simplified expression is 9x. Now let's simplify 7x minus 5x minus x. Once again, our operations are all the same, so we simply need to work from left to right. 7x minus 5x will give us 2x, and then we still have our minus x to work with here. 2x minus x leaves us with simply 1x. Let's do one more. 9x minus 3x plus 2x. Addition and subtraction are paired, so we're going to work from left to right. Let's see, so 9x minus 3x gives us 6x plus 2x. And now 6x plus 2x gives us 8x. So our simplified answer is 8x. Okay, this section is full of lots of practice problems. Here's some more for you. For each of these problems, please simplify. So you should come up with an answer that is one coefficient with one variable. Press pause while you work, and we have one last idea before we wrap this chapter up. Now let's learn to collect like terms to simplify an expression. This figure shows a parallelogram. Find the perimeter of the parallelogram. Okay, so to find our perimeter, we need to add each side length together. So let's begin with r centimeters plus 8 centimeters plus r centimeters plus 8 centimeters. All right. So now let's go through and identify our like terms. We have two different kinds of terms. We have our variables, r, and we have our numbers, 8. So we're simply going to collect those terms and put them together. So let's rewrite our statement as r centimeters plus r centimeters plus 8 centimeters plus 8 centimeters. Now we simplify. R centimeters plus r centimeters gives us 2r centimeters plus 8 centimeters plus 8 centimeters gives us 16 centimeters. So our final statement is 2r plus 16 centimeters is the perimeter of our parallelogram. Now let's simplify 5x minus 2 plus 3x. The first thing we need to do is identify our like terms. So what that means really is that we'll put all of our x's together. So 5x, and we're going to move our 3x. And don't forget, the sign in front of it is stuck to that. So the plus moves with it. And now we put our 2 after that. Remember, the negative sign sticks to it and moves with it. So now our simplified statement will be 5x plus 3x equals 8x minus 2. Okay? Now be careful. Make sure you remember to have those signs stick to the number that's right after them. If you were to write it this way, 5x minus 3x plus 2, that would not be correct. The signs don't stay where they are in the expression. They stick to the number that's immediately to their right or right after them. So what you're really working with is a plus 3x, a minus 2, and a plus 5x. Because remember, there's an invisible plus sign in front of this. Okay, so just remember that and you should be fine. Let's try some practice problems. And here are your last practice problems for 7.3. Simplify each expression. Thanks for your hard work on this. Sorry there were so many practice problems, but it's a new idea, so it's good to practice a lot. When I see you tomorrow, we'll do more work on these together to make sure you understand and to just keep practicing this new skill. I'll see you then.